Okay, let's finish up section 1.5 here. So I want to take a look at a couple of these examples. The first one says identify the parent function of g of x. That would be f of x equals x cubed. And if you look at part C, we're going to have to graph that. So let's go ahead and graph that now. I know my cubic function has these points on it here. It's like -2, -8, +2, +8, somewhere around there. And it looks like that. All right, we can see there are 4, count them, 4 transformations. So let's go through those. The first one, the negative sign, that would give us, that is a vertical reflection. The second one, the 2, that is a vertical stretch by a scale factor of 2. The third one, the -1, that is a horizontal translation, and that will be moving the graph right 1. And the last one is a vertical translation, and that'll be moving the graph down 3. All right, so there's a process to go through to graph all these, but best case scenario here, let's just kind of plot the middle of the graph. So let's do that first. The middle of the graph is going to be moving right 1 and down 3. So right 1 and down 3. This is going to be our new middle of the graph. 0, 0 is going to move to 1, -3. All right, and then just pick a couple points, and you can use math and logic to kind of figure out the rest of the y values here. So for example, if I put 0 in, I would get -1 cubed, which is -1, times -2 is +2, -3 is -1. So 0, -1 is a point. And using that same math, if I put 2 in, I would get 1 cubed, which is 1, times -2, which is -2, -3, which is -5. So 2, -5 is my other point. And you should see here, the graph should be flipped or, vertically. It should also be much thinner than before, and it's moved a little bit to the right and down. I'm supposed to use a dash curve for that first one, so let me switch that to a dash curve. And there you have it. So if at any point during this, if you want to pause it and try some on your own, so if you want to pause it and try number 5 on your own, you're welcome to do so. Otherwise, I'm going to forward ahead. The parent function here is root x. So if we graph that, I know 0, 0, 1, 1, and 4, 2 are my key points here. Okay. And for this one, this is a tough one here, because what you want to do is you want to get this to, all I'm going to do is I'm going to switch what's underneath there. It's going to say -x plus 2 plus 1. That's important, because looking at that, you might not know that there's 2 transformations underneath there. But really, if we factor an x out of that expression there, I'm left with that. Right? And now that's going to tell you a lot of things, okay? But it might be easier if we just rewrote the equation. Oops, I add an extra negative sign there, I'm sorry. Might be easier if we just rewrote the equation like this, because now we can see the 2 different transformations happening underneath the square root. Okay, the first negative sign out in front there, that is a horizontal reflection. And then the -2, and that's the key here, because a lot of kids, if you don't rewrite it, you'll get this part wrong. Okay, you'll see the +2 in the beginning, and you'll think, oh, that's going to move it to the left. But really, it's -2 here, so that's going to end up moving it to the right. That's why I highly suggest that you rewrite it like this first. All right, so let's go ahead and take a look at the 3 transformations happening here. I got one highlighted already there in orange. Here's a second. And then here's a third one. Not in any order. So the first one I already talked about, that is a horizontal reflection. Hopefully you can see my light green pen here. The second one is a horizontal translation. That is going to move to the right 2. And then finally we have a vertical translation. And that's going to move up 1. I should have wrote that in pink to match my highlighter. Okay, again, how do I know if it's horizontal or vertical? The negative and the -2 are under the radical sign, so I call that inside the function. That means it's horizontal. The +1 is outside of the radical sign, so I call that outside the function, which means it's vertical. Okay, so graphing this, I know the points are going to move up 1 and right 2. So I'm going to take 0, 0, and move it up 1 and right 2. Okay, and then we're going to take that whole thing and flip it horizontally. So instead of going to the right, it's going to open to the left. So 1, 1 will be going to 1, 2, and 4, 2 will be going to -2, 3. Again, what you can always do is just take x's, plug them in, and get y's back. So if you put 1 into that equation, you would get root 1 plus 1, which is 1 plus 1 or 2. And that's where I got 1, 2 from. Once again, if you want to pause the video and try 6, you're welcome to do so. Otherwise, you can follow along as we go here. And also, once again, we see 3 transformations. 1, 2, 3. And I'm going to rewrite this one a little bit as well, just so you can kind of see one thing I'm talking about here. All I'm going to do is I'm going to take this 3 and I'm going to bring it outside of that to multiply it. You'll see why I do that in a little bit. This is the rational function parent function. So if I was to graph that, I know that x equals 0, y equals 0 are asymptotes. The point goes through -1, and our side goes through 1, 1. So there is my parent function. All right, 3 transformations. The first one, we got not any order, but the pink one that I see there is a vertical stretch. By scale factor 3. The green one is a horizontal. How do I know it's horizontal? Because it's inside the function. So it's a horizontal translation. And since it says x minus 2, it's going to be right 2. And then the -1, since it's outside the function, is a vertical translation. And since it's minus, it's going to be down 1. So the reason why I rewrote that the way I did is so I can see that 3 is technically outside of the function. That's how I know it's vertical. Okay? In order for it to be inside the function, you have to be in the denominator. You have to say 1 over 3x minus 2 or whatever. Okay, so that's how I know that it is indeed vertical. So I know I want to move the asymptotes right 2 and down 1. Okay, again, then you can just pick some points if you need to. If I was to put 3 in here for x, I would get 3 over 3 minus 2 minus 1. So that's 3 over 1 minus 1. So it's 3 minus 1 or 2. So point 3 comma 2. And you can keep trying more points here. So let's say I put 5 in there. 5 minus 2 is 3. 3 over 3 is 1. 1 minus 1 is 0. So 5 comma 0. So now I kind of know what this graph looks like on this side. And you can just keep picking more and more points until you know what it looks like. That should be enough for that side. Now go to the other side. Maybe put 1 in for x, or 0 or negative 1, until you have a good grasp of what this would look like. If I was to put 1 in for that, I would get 3 over negative 1 minus 1, which is negative 4. And if I was to put, let's say, negative 1 in, I would get 3 over negative 3 minus 1, which is negative 2. And again, I have a pretty good grasp of what this graph looks like now. Let me change my original graph to dotted. Make sure I follow my own instructions. Maybe it won't let me. I don't know what that just did. Okay. I don't know why it's telling me the pace. Finally. At the last page, we're just going to talk about piecewise functions. Piecewise functions should not give you any trouble as long as you're understanding our parent functions. All we're going to do is be graphing 2, 3, or 4 of them at once over different intervals. So in the first one, I'm going to use 3 different colors here. I'm going to use red for the first one. I'm going to graph the function x plus 1, but only between these x's. Okay, and important to note, at negative 6, we'll get a closed circle. At negative 2 will be an open circle. Okay, so what I'm going to do is I'm going to put negative 6 in for x. Negative 6 plus 1 is negative 5. So we'll point negative 6, negative 5. Sorry, my graph is cut off there, but you get the picture. Negative 6, negative 5, somewhere around here. And I'm going to put negative 5 in, negative 4 in, negative 3 in, negative 2 until I know what this looks like. Okay, so negative 5, negative 4, negative 4, negative 3, negative 3, negative 2, and then negative 2, negative 1, but that gets an open circle. And this should just be a diagonal line that looks like that. Okay, and then the next one I'm going to use blue for. That's just a horizontal line, y equals 5. Okay, and that's going to be between negative 2 and 3. And both of these will get closed circles. So between negative 2 and positive 3, I'm just going to graph the horizontal line, y equals 5. And then finally, between 3 and infinity, put open circle at 3. I'm going to graph this line. So again, just plot as many points as you need until you know what it looks like. If I put 3 in, I would get negative 2 times 3 plus 3, which is negative 3. And that's going to be an open circle. And if you need to keep putting more points in, you're welcome to do so as well until you have a good handle of what that looks like. Basically, it's going to be just sloping down forever, like this, with a slope of negative 2. And that's what that graph will look like. Second piecewise function here, we have 4 pieces. So the first piece is when x is less than or equal to 0, and that's a line, negative 2x plus 1. So if I put 0 in for that, I would get positive 1. And it's a closed circle because it's less than or equal to. And now it says less than, so we're going to the left here. You could put x's in, or you can recognize it's just a slope of negative 2. So instead of going down 2, right 1, I'm going to go up 2, left 1 until I know what that looks like. There's my first piece of my piecewise function. Second piece I'll use red. That's between 0 and 4, but both of those are open circles. If I put 0 in, I get 1 back. Hey, we already have a point there, so that's okay. If I put 1 in, I would get 2 back. I'm not going to put 2 or 3 in because they're going to give me decimals. I recognize that. But if I put 4 in, root 4 plus 1 is 3. So 4 comma 3. And that should be an open circle as well. So there's my second graph. My third graph is just a point. If x is 4, y is 4. So graph the point 4, 4. And my last piece is part of a parabola between 4 and 7 with an open circle at 4 and a closed circle at 7. So if I put 4 in there, I would get negative 1 squared, which is 1. So 4, 1 is an open circle. If I put 5 in, I would get 0 back. If I put 6 in, I would get 1 squared, which is 1. So 6, 1. And finally, if I put 7 in, 7 minus 5 is 2. 2 squared is 4, so 7 comma 4. And there's my piece of my parabola. And that's my piecewise function. Okay, lastly, number 3 here says, write a definition for the piecewise function defined below. So again, I'm going to use some different colors here so you can match things up. Here's the first piece. And this one is actually the first piece because we want to read left to right here. Let's write the domain down for that first. The domain is from -5 to -1. And we include -5 and -1 because they're both closed circles. So what's the equation of that graph? Well, it's just y equals 1. So y equals 1 will be my first domain. Will be my first expression. Over the domain -5 to -1. Okay, my second piece looks like part of a parabola. Okay, so let's first write the domain for that one. The domain for that one, oh, it looks like, actually, I'm sorry, I'm having trouble reading this graph. The first domain actually goes to 0. So the second domain would go from 0 to 3. These numbers are a little tricky to read here. 0 to 3. And it does not include 0 because of the open circle right here. But it does include 3 because of the closed circle right there. Okay, so like I said, I know it's a parabola. Okay, it does not look like it's shifted right or left, but it is shifted up. And there's also a vertical reflection because it's opening down. So the equation of this parabola, remember this is the parent function, x squared, right? But it's going to be a negative out in front because it's reflected down. And we're going to subtract 3, add 3, I'm sorry, because we're shifted up 3 units. So negative x squared plus 3. Okay, and our last piece looks like a line, a diagonal line there. Let's write the domain for that first. That's going to go from 3 to infinity, so that's just x is greater than 3. Okay, so now we got to find the slope and intercept of that line. Well, the slope, that's just 3. Look at up 1, 2, 3, right 1. So the slope is just 3. So I know this is going to be 3x. So now what's the intercept? Well, we don't know what the intercept is, so what you could do, there's 2 different ways to do this. You could count down 3, left 1, down 3, left 1, down 3, left 1 until you got to the intercept. Or you can write this in point slope form. I know this point right here, 4 comma 5, is on that line. So point slope form, y minus 5 equals 3, x minus 4. Distribute the 3. And add the 5 over. you get 3x minus 7 as your equation. So that's it for section 1.5. Complete the homework by Monday and have a good weekend.